Welcome to our solar system, home to the Sun and all things that orbit it. That includes the Earth, other planets, asteroids, comets, and human-made objects like the James Webb Space Telescope, one of NASA's windows into systems beyond our own. The spinning collection of rocks, gas, and dust is bound in an intricate dance dominated by the Sun's gravity. The system is spread across an enormous space, making it difficult to grasp the minuscule size of planets and other objects compared to the distances between them. Webb's secondary mirror is 0.74 meters, 2.4 feet, across, made of beryllium and thinly coated in gold. Beryllium is stiff, lightweight, and stable at very cold temperatures, but 3.4 grams, 0.12 ounces, of gold enables the mirror to efficiently reflect infrared light. Webb's 6.5 meter, 21 foot diameter primary mirror is a gold-coated beryllium reflector used to capture faint amounts of infrared light. The 5 ultra-thin layers of Webb's sunshield block 99.9999% of the infrared light from the Earth, Sun, and Moon to keep the telescope cold and able to detect distant infrared light. The Integrated Science Instrument Module houses 4 science instruments, NIRCam, NIRSpec, NIRI, and NIRIS, that are used to capture images and spectra and measure infrared light. The spacecraft bus is the brain of the telescope. It hosts computing, communications, propulsion, and structural components. Webb's solar panels always face the sun and convert sunlight into electricity to power the telescope. To humans, this is the most important star in the universe. The Sun is the star of our solar system, providing key ingredients for life as we know it: heat for liquid water, fuel for plants, and the gravity that holds it all together. In a solar system of Roman gods, Uranus is the only planet named for a Greek deity, and that's not the only way it's unique. Nicknamed the Sideways Planet, the ice giant's 13 rings appear almost vertical because the planet itself is tilted, with its equator almost straight up and down, possibly the result of a long-ago collision with an object the size of Earth. With sulfurous clouds and methane in its atmosphere, probably doesn't smell too good here, but the methane also gives Uranus a lovely blue color. Welcome to Venus, the hottest planet in our solar system. Its thick atmosphere traps so much heat that it creates a greenhouse effect, raising the surface temperature to around 900 degrees Fahrenheit, 465 degrees Celsius. Hot enough to melt lead. Welcome home. Earth is our beautiful oasis in space, and its story is our story. Third planet from the Sun, warm enough for liquid water, yet protected from harmful rays and meteoroids by an atmosphere that is rich in nitrogen and oxygen. Don't While moons that orbit other planets in the solar system have proper names, our moon, Earth's moon, is simply the moon. Unlike Earth, the moon does not have an atmosphere that protects it from meteorites, and evidence of impacts can be seen all over its surface. Spacecraft first explored the moon in 1959, and humans first walked on the moon in 1969. No planet has captured the human imagination quite like this one. The famous red color is the result of rusting. Phobos, the larger of Mars's two moons, has orbited a rocky road around the red planet. Its surface shows evidence of thousands of meteorite impacts. No planet has captured the human imagination quite like this one. The famous red color is the result of rusting iron minerals in the soil. Many exploratory missions have shown us that today Mars is a desert world with a thin atmosphere, but it may have had a wetter, warmer past. You've reached Pluto, at the edge of our solar system in the region called the Kuiper Belt. It is a small but fascinating dwarf planet, about 2/3 the width of Earth's moon. With blue skies, snow, and mountains as high as the Rockies, it may seem a little like home, but don't be fooled. When it snows on
Welcome to the Orion Nebula, more than 1,300 light-years from Earth. This stunning cloud of hot gas and dust is home to 10,000 new stars, many with planets forming in protoplanetary disks around them. The James Webb Space Telescope can observe young systems like these to determine what the earliest days of our own solar system may have been like. A puffy young sun in the center, orbited by a disk of colliding gas and dust condensing into planets. Scorching hot temperatures dominate the inner edge of the disk as dust and gas swirl around the ball of hot plasma that is the young star. Away from the center, the heat from this blazing furnace cools as light disperses through the disk and is blocked by gas and dust. Eventually, the temperature dips to a point where ices form, the snow line. This region lights up in the infrared and can be explored by the Webb telescope. Explore the enormous effects subtle changes in temperature have on the structure of forming planets. Congratulations! You've made a rocky planet. This is the first of 3 types of planets you can create. See the Science tab for more info. Congratulations! You've made an ice planet. This is the third of 3 types of planets you can create. See the Science tab for more info. Congratulations! You've made a gas planet. This is the second of 3 types of planets you can create. See the Science tab for more info. Welcome to the Orion Nebula, more than 1,300 light-years from Earth. This stunning cloud of hot gas and dust is home to 10,000 new stars, many with planets forming in Deep within the cosmic dust of the disk, young planets are beginning to take shape under the watchful eye of the Webb telescope. Turbulent motions in the gas cause minuscule dust and ice particles to collide, some forming new planetesimals, bodies approximately 1 kilometer in diameter or larger. These planetesimals can be drawn together by gravity and may go on to form planets. Manipulate boulders of silicate rocks and frozen ice to build a planet. Open the Science tab to select different particles or change the Welcome to the Orion Nebula, more than 1,300 light-years from Earth. Far from the shrouded abyss of the protoplanetary disk's interior, the veil of whirling gas and dust thins, bathed in the radiance of the young. Open the Science tab to discover how light interacts with molecules. Far from the shrouded abyss of the protoplanetary disk's interior, the veil of whirling gas and dust thins, bathed in the radiance of the young star. The molecules of gas are sent spinning, vibrating, and breaking apart to later combine into new forms, forging materials that may become the building blocks of planets and everything that lives on them. Explore how different types of light interact with gas molecules that are expelled from the disk. Infrared light can cause molecules to spin and vibrate. Visible light passes through with little effect. Ultraviolet light is capable of breaking apart molecules. Microwaves cause some molecules to spin. Infrared light can cause molecules to spin and vibrate.
A massive beast lurks at the heart of almost every galaxy. A supermassive black hole that silently spins and occasionally feeds on stars, gas, dust, and anything else that drifts within its event horizon. As it ingests matter, it grows ever so slightly, expanding its sphere of influence and emitting powerful jets that the Webb telescope can study. Fire stars into the vicinity of a supermassive black hole to see how it grows. Welcome to one of the trillions of galaxies that make up the universe. This immense collection of stars, dust, and gas, swirling in an enormous spiral galaxy, is one example of the complex systems the James Webb Space Telescope can study. Almost all the matter in the universe is contained in galaxies like this one. Stars are born and die as the galaxy slowly drifts through the cosmos. Beyond sight, dark matter subtly tugs on the matter we see. Each small piece of the galaxy connects with the others in some way, affecting how the system develops over time. Stars fill the galaxy. These twinkling points of light are constant of the cosmos during the brief lives of humans. But stars are also individuals that live and die, growing, changing, and collapsing in varied ways depending on the amount of matter they contain. The molecules in and around these aging stars can be studied by the Webb telescope. Explore how the mass of a star affects the course of its life.
The solar mass of a star determines the age, life cycle, growth phases, and eventual collapse of the star. A star's life cycle varies depending on the amount of solar mass it has. The lifespan of a star can range from millions to trillions of years old. See the lifespans of different types of stars. The age of the star has changed dramatically. Use the controller by pressing and holding the touchpad to drag the marker on the timeline. See what the star looks like at different ages. For most of its lifespan, a star grows in size, expanding its radius. Notice how the size is measured here. The star's current phase is shown here. Continue to see how the star develops over its life. This star has run out of fuel and reached the end of its life cycle. Use your right controller to play or pause the cycle again, or travel to explore other stars.